Use the data below to find the correlation coefficient R. The data includes the finishing time of the New York City Marathon and the temperature on the day of the race. And then we have some summary data values here, which is basically the column totals when you sort the data and do that little bit of work that we do in the beginning with the numbers provided. So they're asking us to find the correlation coefficient R, so it's very clear that we're going to need that formula. Let's take a look at that formula quickly. The formula for R involves us calculating the sum of squares for x, y, divided by the square root of the sum of squares for x, x, times the sum of squares for y, y. All right, so in order to do this calculation, what we need is these sum of square values. So let's just work those out one by one, starting with the sum of square x, x. Now, we can then move to sum of square x, y, and then finally finish with sum of squares y, y. The formulas for these values are as follows: the sum of x squared minus the sum of the quantity x squared divided by the n value, and the n value here would be the number of word pairs we began with. Now, sum of square xy is going to be the sum of the xy term minus the sum of the x values times the sum of the y values, all divided by n. And then for the sum of square yy, we'll have the sum of square for y squares minus the sum of y quantity squared over n. So let's plug the numbers in that we were given in this problem. So we have the sum of x squared provided to us. That's 29,070. 29,070 minus the sum of x. The sum of x is 478. And that value will be squared, divided by n. Now n is the number of pairs we have. That's 1, 2, 3, 4, 5, 6, 7, 8. So we had 8 pairs. For this formula, we have the sum of xy, and that's 70,318.99 minus the sum of x times the sum of y. If you look there, that's 478 times 1,176, 1,176.617. And then finally, we divide all that by 8 again. All right, and then the last value we have here is the sum of squares yy, which is going to be 173,068.7 minus the sum of y quantity squared. The sum of y is 1,176, so 1,176.617, that quantity squared divided by n, which is 8. Okay, so we have these values now. We have the formulas for them. And as we work them out, we'll just plug the numbers in directly into our formula here. Okay, so let's start with the top then. Let's get the sum of square. Actually, let's do them in order that we have them above there. So we'll get the SSXX value first. So let's work that one out and see what that gives us. So we're going to have 29,000. That's 29,070 minus 478 squared divided by 8. Hit enter, and we get 509.5. So I'm going to put that right here where it belongs. 509.5. Then we're going to multiply that by the sum of square yy. First, let's do the sum of square xy, which is our list in the next position. So let's see that one. It's 70,318.99 minus 478 times 1176.617 divided by 8. So you just put it in exactly as you see it. You don't need any special parentheses. The calculator will not make a mistake here on the order of operations. So you just enter it as you see it. And when you're done, you get the value 16.124, so on and so forth. So 16.12425. Okay, now from there, we're going to do the top, which is the sum of squares for, oops, I'm sorry, that was our sum of square for xy. I almost put that answer in the wrong place there. That'd be 16.12425 on top. And this value here is actually the sum of square of yy, which is our next value. Okay, so let's work that out now. To work that out, we're going to have 173,068.7 minus 1176.617 squared, and then we divide that by 8. Okay, so again, just double checking, 1176.617 squared divided by 8, hit enter, and we get the answer 15.25, etc. So this should be 15.25441387 using all the decimal places. Okay, so those are our values. Now let's take those values and plug them into our calculator and calculate our R value for the problem. So we're going to have 16.12425 divided by the square root of, and the square root here will be 509.5 times 15.25441387. Okay, all that's in there. Close up your square root, hit enter, and we come up with the answer 0.182 ... And if we round off, it's going to be essentially that R is approximately equal to 0.183 when we look at our answer there in our calculator. Okay, so if that's our value, you see that we only have 0.18 for R. And remember, that's relatively low. So that means that there's not a strong linear relationship between the finishing time and the temperature outside on the day of the race. So remember, a strong R is something, if it's positive, a strong R would be something in the 0.9 area or 0.8 or maybe even 0.7, right? But as we get closer and closer to 0, it becomes more and more weak, the linear relationship. And so in this case, the linear relationship is fairly weak. We're only in the 0.18 area, right? So we're not even at 0.2 yet. All right, that's probably why when we did our hypothesis test on the slope, we were unable to reject the null hypothesis, which says there's possibly no linear relationship between these two variables.